Hello and welcome to another session of Streaming School. Thank you so much for joining us again. It gives us a great pleasure to welcome Mr. Sam Winch. Good morning, Sam. How are you, buddy?
Good morning, everyone. Yeah, very good. Thank you. Another day. What is it? Is it Friday today?
Yeah, looking smart. So there's no sports today, buddy. Looking smart today.
I'm trying. I was going to go with a tie, but maybe a bit too much just with the heat and stuff. Maybe a bit too warm. But yeah, I've gone with it all white today. Hope you like it.
Good man. Yeah, I went with pink, and obviously I'm ruining everyone's screen. Is that the beard? Is it a lockdown beard, or is that?
I know. Yeah, and do you know what's worse is that I bought some beard dye, so I hope that doesn't. That the viewers don't plummet because of that. We're going to give that a go this afternoon, and if all else fails on Monday, it's either going to be clean shaven or a darker brown colour.
Oh, amazing. So I actually finally went into one of those, those free trials for the beard thing. There's so many free trials for razors. I thought, I'm not going anywhere for a while. Let's give that one of them a shot. So yeah, hopefully we'll be all nice and neat next week. But I look forward to seeing your multicolored beard. And that's definitely the start of the bad maths. If Mr. Winch uses this much dye and this much beard, how much all yours, buddy, all yours.
We go. Right, we'll quickly move on from my beard, and we'll talk about today. So today we're going to quickly recap what we did on Wednesday, and then we're going to move on to angles today. So we're working on interior, well, in fact, loads of things. I think we've got 8 things all together on the list, so a lot to get through, as always, really. But Nish, if you could start by sharing my screen, please.
All right.
And we'll start off by recapping what we did on Wednesday. So we spoke about factorization of quadratic equations, and we're going to look at a little bit of that today just to cap off what we did. We did Pythagoras Theorem and 3D Pythagoras as well, which is where we start straight away with Pythagoras Theorem. This is 3D Pythagoras Theorem. So as you can see on the screen, here you've got a cuboid, a 3D shape, and they would ask to calculate the line A to F. So the question is, how do you do that? Well, you've got to make a triangle. So you've got 6 centimeters here, and 8 centimeters, and 7 centimeters here. I'm not sure how to make a triangle. So what we're going to do is, if you look at the next screen, I've drawn a line across. Now here I can make the triangle with 6 centimeters and 8 centimeters. And of course, I'm going to square them. And then that would give me a number here that I can find the square root of. So if I can, excuse me, if I can share my screen, we've got 6 squared, which of course gives us 36. I'm going to add that to 8 squared, which of course gives us 64. And then in total, we've got 100. The square root of 100 gives us 10. So now what we know is that the line A to C is equivalent to 10 centimeters. So this line here is 10 centimeters. Now we can use this line up here to give us, which is 7 centimeters. So then I've got A squared and B squared. 10 centimeters squared, of course, is 100. You already know. 7 squared is 49. So then that gives me 149. And if I square root 149, that will give me the line A to F. So square root 149, which is my trusty calculator, equals 12.2 if we round into one decimal place, and that would be the line A to F. So when you're doing 3D Pythagoras, you're often going to have to find a triangle within the triangle, if you like. So here I've created the line A to C, as you can see on the screen, and that allows me then to have a second line to work out the line A to F. Okay, so I hope that helps for Pythagoras, 3D Pythagoras, and that was a little example. But moving on to today's lesson, as you can see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 things to do. Today, we start off by looking at the sum of angles at a point, then we move on to angles on a straight line, angles in a triangle, angles in a quadrilateral, vertically opposite, alternate, supplementary, and corresponding angles. And then we finished today's lesson with interior and exterior angles of a polygon. Okay. Now, if you look at all these, it crosses a range of different grades. So we would start within the foundation paper only, down to grade 3, and then we'd move up nicely to a grade 6 and 7 with some interior exterior angles using decimals and even fractions as well to find the exterior angles, and loads of algebraic notation as well when we're doing interior and exterior angles. So we're working through both papers today. And we'll start off just working on the sum of angles at a point. So here we can see you've got four different shapes within this 360 degrees. And of course, we know that A plus B plus C plus D would give us 360. So, for example, if we knew that 3 of them added up to 240, then D, for example, would have to be 120. And we'll come back to an example of around a point later on. But now we're going to look at the first 4 questions of today. So it's looking at angles on a straight line and angles in a triangle. Now, I chose both these because both add up to the same thing. Of course, angles in a triangle add up to 180, and angles on a straight line add up to 180. So if you can remember that at home, the angles on a straight line add up to 180, and angles in a triangle add up to 180. And if I can just zoom in, nice and easy, we can have a go at the first 4 questions today. So question 1, we've got x, and then we've got 51 degrees. So we could go 180 minus 51, which of course gives us 129 degrees. And if we looked at the picture itself, now more often than not, they will write a quote that says not drawn to scale, or picture not drawn accurately, or something along those lines. But of course, it still will give you some sort of guidance. So we know here, because it's an obtuse angle, so it's past 90 degrees, we know that it's going to be within plus of 90 degrees. So it's going to be 129 degrees, fits that nicely. And 129, add 51, of course, gives us 180 degrees. The difference with number 2 is that you've got 3 angles. We've only got one number, which is 30 degrees. So if we do 180, subtract 30. But of course, this shape here that we know that is a right angle triangle, which we know is equivalent to 90 degrees. So we can subtract 180, we can subtract 30 and 90 from 180, which means that x must equal 60. Brilliant. Okay, if we move over to question 3, so they're angles on a straight line. Angles in a triangle, we know add up to 180. So again, you've got three angles. You're given the value of 2 of them. So we simply 180 subtract by 26, subtract by 111. So we know that 26 and 111 is 137. 180 subtract from 137 is x equals 43. And finally, number 4, again, you're only given one value, which is 24 degrees, but we know in the corner here we've got a 90-degree angle. So we've got 24 and 90 degrees to subtract, which altogether is 114. 180 subtract from 114 gives us 66. So x equals 66. Okay, brilliant. So they're angles on a straight line and angles in a triangle. Here we're going to work on angles in a quadrilateral. Now we know that angles in a quadrilateral add up to 360. So we've got 180 for triangles, 360 for quadrilaterals, and you might start seeing a pattern so that in a short while you'll be able to work out what 5-sided shapes are, so polygons such as 5-sided shapes like pentagon, hexagon, etc. But at the moment we're working on quadrilaterals. A 4-sided shape adds up to 360. So with this first shape here, it's not quite kite. It says that it wants us to work out the angle of x. So if we were to add up, load up my visualizer again. If we can add up all the angles so far given to us within the quadrilateral, which is 109, add 83, add 115, which would give us 307, and we subtract that, of course, from 360, which would give us x equals 53. Okay, Brilliant. Now, question 2, we can see down here, we've got ourselves a parallelogram. So we know in a parallelogram that there's 2 sets of parallel lines. So you've got the line here on the left-hand side, the 2 vertical lines, if you like, they are parallel to each other. So therefore, angle X and angle Z are the same. Here, we've got the angle 73 degrees. So we know that 73 degrees in the bottom left and the one in the top right are the same. So remember that those within a parallelogram, opposite angles, diagonal opposite angles, are always the same. So with that in mind, if we're back onto our visualizer, we can see that they must add up to 360. 360 subtract by 73 and subtract by 73 again. Well, that gives us now 146. So that would put us on 214. 46. So then we've got 214 remaining. That needs to be split between X and Z. Now, because we know that X and Z are the same angle, we can simply divide that number by 2, and we would get our answer for all the terms. So we've got 214 divided by 2, which of course gives us 107 degrees. So X, we've said, is 107. Its opposite partner Z is also 107. And Y, as we said earlier, is opposite to the bottom left angle here. So that must be 73 degrees. And finally, we've got one in the top hand corner. If I could just move my visualizer screen slightly down. It wants us to work out the values of X and Y. Now, slightly different. You're not given any angles within this parallelogram. You're not given any angles. But again, like we've just said, we know that within a parallelogram, the diagonal angles are the same. So X and this interior angle here are the same. Now, as we spoke earlier about angles around a point, we know they add up to 360. So with that in mind, if I said 360 subtract 304, which equals 56, then I know that X must be 56 because the angle here in the bottom left-hand corner is 56. So that's 56. X equals 56 also. And now what I'm going to do is add them both up to give me 112. And if I said 360 subtract 112, which gives me 248. So then angle Y and its opposite diagonal angle here would add up to 248. They're both the same, so I can divide them by 2 to give me 124. So X is 56 and Y equals 124. And once again, although not drawn accurately or drawn to scale, we can see that this angle here is less than 90 degrees, so 56 for X. And we can see that Y is an obtuse angle, so it's beyond 90 degrees, so 124 would make sense. If it was the other way around, it might mean that I'll have to go back and look at my answers. Okay, so we're moving nicely on to vertically opposite angles. Now we know that vertically opposite angles are the same, so quite straightforward. If the angle opposite to A is 45 degrees, then A is 45 degrees. Now remember, angles around a point add up to 360, as we've already said. So if I was to be asked what these two angles were, then I would just go A equals 45, add 45, which we've already got here, which gives me a total of 90. And if I was to subtract 90 from 360, which of course would give me 270. So therefore, if I divide that by 2, I've got the two other angles if needed, which was 135. Of course, remember they're opposite angles, so they are the same. Same with question 2. We'll quickly break it down for you. We've got M must be 145 degrees because it's an opposite angle. So altogether so far, I've got 290 degrees with 360, subtract by 290, gives me 70 degrees. So I now need to share 70 degrees out between the two remaining angles, which is n, and the one opposite n. So n equals 35, and so does the opposite angle to that. Okay, so we're racing through all the points. In fact, there's 2 more to go. We're going to look at now alternate, supplementary, and corresponding angles. Now, another term for supplementary might be co-interior. They are angles within the parallel lines. But we'll start off with alternate angles. We use the Z shape, and it can be a Z going that way, or it might be a Z in a different direction as well. And we'll go through that in a second. But alternate angles are the same, so they're equal to each other. So here you've got A and C, so therefore they must be the same degrees. Flipping over to corresponding over here, you can see an F angle. So in the yellow, it's drawn as an F, and they are called corresponding angles, which are also equal. And then finally, supplementary angles, which have to add up to 180. So for example, if B was 130 degrees, as it looks like it could be, then that A would have to add up to 180, so it would be 50 degrees. Okay, so I have a complete worksheet of angles on parallel lines. So if I just flip back to my visualizer, and we're looking at this sheet here, I'm just going to open up my visualizer, so now you can see my whole screen. And if we zoom out a little bit as well. So the first question here, you've got A, B, C, and 110 degrees around a point. So we know that A, B, and C adds up to 360. And we also know about alternate and corresponding angles. So we're going to start off by looking at what the question says. Write down the letter of one other angle of size 110. And I'm going to choose the letter F down here. The reason why I chose the letter F is because corresponding angles are equal. So with corresponding angles being equal, that means that D must be 110 degrees. And opposite angles from D are also the same. So remember, your corresponding angles is your Z term. So if we were to draw a Z here, like so, then that and that would be the same, as well as that and that would be the same. Okay, so that would be 110, and therefore F would be 110 also, because it's an opposite angle. Give a reason for your answer. Well, exactly those terms. So you get 2 marks for using the word corresponding or the word opposite and explaining that they're both equal. So if I was just to write corresponding angles are equal, and opposite angles are equal. So 2 different reasons for my answer gives me 2 marks. Altogether, I get 3 marks because I chose the letter F as well. And then we'll move on to the last one here, down here. And we've got 32 degrees, 125 degrees, and they want us to work out angle X. So here I know that co-interior or supplementary angles that we spoke about add up to 180. So therefore, 32 and X must add up to 180 because they are supplementary angles. So if I was to say 180 minus 32 equals 148 degrees. And supplementary angles equal 180 degrees. Nish, if you could share my screen, please.
All right. Cool.
So we've not quite got to interior and exterior angles, but we'll I'll catch up with you on Monday, and we'll recap everything we've done today and go through in more detail interior and exterior angles, because that's the stuff that you're likely to see on the higher paper. So we'll spend a bit more time on Monday going through that. But I hope you enjoyed today's lesson. We got through 8 of the 9 things. So have a good Friday, and I'll see you soon.
Wonderful. Thank you so much, Sam. I hope you have a great weekend, buddy.
Cheers, guys. Take care.
Bye. Nish, so what's going to happen next? Nish, what lesson is it?
Next we have a science lesson with Michael Scott.
Michael Scott, brilliant. And then we will have a small break, and then we will come back for the first of our wellbeing lessons.
Yep.
All right, brilliant. I'll give you the screen.
All right, cool, thanks. So here is the optional task for maths. It is a worksheet. I think there are 11 questions on it. And they're all to do with angles, so all things that Sam went through today. Please have a go. I will put the links up to everything on Facebook and on YouTube, and if you've missed the previous lesson, you can find that on Facebook and YouTube as well. Yeah, that's it.
Brilliant. Thank you so much, Nish. I will see you in 19 minutes.
Yeah, see you in 19 minutes.
Catch you in a bit. We'll do that thing where I think I've ended it, but I haven't, and then I talk about something.